Okay, so in this video we're going to look at rational inequalities. And in rational inequalities we could get something like this, where you're asked to find the range of values of x for which 4x minus 1 over x minus 3 is less than or equal to 2. This is a very common kind of question that comes up, and for the most part it's quite straightforward, except for the last few lines of the question. I think that a lot of students, if you've never seen this before, your first instinct would be to eliminate the fraction. And by instinct, the easiest way to eliminate the fraction is to multiply both sides by x minus 3. If you multiply the left hand side by x minus 3, it might look like this. The x minus 3 on the bottom and the x minus 3 on the top would cancel, and the right hand side you would have to also multiply by x minus 3. That would be intuitive, that's what you might think you have to do. However, if you do that, you're going to miss one of your answers, you're going to lose an answer. If you have an algebraic fraction and an inequality, you need to multiply both sides by the bottom of the fraction squared. So I need to multiply both sides by x minus 3 to be squared. So this is an exception that comes up a lot. In a scenario like this, you multiply both sides by the denominator squared. Now let's have a look at what happens here. I have an x minus 3 on the bottom, which will divide into one of the x minus 3's on the top on the left. So I'm actually just left with x minus 3 times 4x minus 1. Well, on the right hand side, I'm going to have to multiply that out. So on the left, you have double brackets. It would be the first thing in the first bracket by the second bracket, then the second thing in the first bracket by the second bracket. If you multiply it out and simplify, you would end up with 4x squared minus 13x plus 3. Obviously, you need to work that one out. You don't need to skip all of those lines. On the right hand side, you should multiply the brackets first. So leave the 2 as it is and multiply x minus 3 by x minus 3, and you would get x squared minus 6x plus 9. Now clearly here we have an x squared, we have an x, and we have a number, which means we're going to have a quadratic equation. But before I bring everything to one side, what I need to do is I need to multiply out the right hand side. So I can just write this as 2x squared minus 12x plus 18. And at this stage, since I've identified that it's going to be a quadratic, I might move everything to one side. And I could rewrite this as 4x squared minus 2x squared minus 13x plus 12x plus 3 minus 18 is less than or equal to 0. I would always advise students to move everything to the side where the x squared will be positive. Clearly 4 is bigger than 2, so 4x squared minus 2x squared gives me plus 2x squared. My x's will become minus 1x and my numbers become minus 15. So now I have this quadratic is less than or equal to 0. You should recognize this as exactly the same as what we did in the previous video. Now I have a quadratic less than or equal to 0. In order to identify where this quadratic is less than or equal to 0, I'm first going to let it equal to 0, factorize and solve it to find the roots, and then sketch my graph, and I'll be able to identify the answer to this. So we started off with this question and we've simplified it down to 2x squared minus x minus 15 is less than or equal to 0. In order to work out where this quadratic is less than or equal to 0, we first let it equal to 0, we factorize and solve it, and we get x is minus 5 over 2 or x equals 3. So if the quadratic was equal to 0, then the roots would be 3 and minus 5 over 2. That is not my answer, but that's going to allow me to sketch the quadratic. I know it's a plus x squared and it crosses the x-axis at 3 and at minus 5 over 2. So again, it just needs to be a rough sketch, so it might look something like this. Now the question asks me, when is it less than or equal to 0? The quadratic is less than or equal to 0 when it's below the x-axis, so it's just one continuous region. So in this case, if I took x values that were to the right of minus 5 over 2, or in other words, bigger than minus 5 over 2, if it's greater than or equal to minus 5 over 2, it's to the right of minus 5 over 2, the quadratic is below the x-axis. But only as far as 3. I have to take values less than or equal to 3. So if x is between minus 5 over 2 and 3, then the quadratic is less than 0. However, I've made a critical mistake here, and I really want to stress this one that often catches people out. I would only get 10 marks out of 15. I would lose 5 marks for what I've written here, because we need to refer back to the original question. There's an impossible value for x, and there's always going to be an impossible value for x in these questions. We haven't come across this yet, but you are not allowed to have a 0 on the bottom of a fraction. If you have a 0 on the bottom of a fraction, it's undefined. If you type that into your calculator now, anything over 0, your calculator will tell you it's an error, it doesn't make sense. So the bottom of this fraction cannot be equal to 0. If x is equal to 3, then the bottom of this fraction would be a 0. Imagine if I subbed in that x was 3. The bottom of the fraction would be 3 minus 3. The bottom of the fraction would be a 0, so the whole question wouldn't make sense. So I am not allowed, it's not possible for x to be equal to 3. And in some Leave Insert exam questions, it will actually tell you that x can't be equal to 3. Although it might not. It might, you need to be able to just look at that and you need to be able to tell that x can't be equal to 3. So what often happens to students is they get to this point, they factorize and solve it, and they get a value of x equals 3, and then they eliminate it and they think it's wrong. The only reason I've done this is so that I can sketch my curve. And now when I get to my answer, I need x cannot be equal to 3, so I just have to eliminate that. So I actually need to describe this as x is greater than or equal to minus 5 over 2, but less than 3. Because it cannot be less than or equal to 3, it can't be equal to 3. If it was equal to 3, the whole question doesn't make sense. So in all of the questions, you should assume that anytime you get a question like this, at the very, very end, you're going to have to eliminate one of your equals. One of them will just be a less than sign, while the other one might be less than or equal to. So that's the bit, the very last bit there, that often catches people out. Other than that, I think this is a relatively straightforward type of question. So after doing one example, I think you're ready to try a few yourself. So I want you to try 3 questions based on that. You're finding the range of values of x for which these 3 inequalities are true. In each case, you're going to multiply both sides by the denominator to be squared. You're going to manipulate it and end up with a quadratic equation. You then factorize and solve your quadratic and sketch yourself a curve. And in each case, be very, very careful about the impossible value for x. For example, in the first one here, x cannot be equal to minus 4. Because if you let x equal to minus 4, the bottom of the fraction would be minus 4 plus 4, which is 0. And in that case, the whole question wouldn't make sense. So I want you to pause the video now, work through those 3 questions, and then compare it to my solutions. Okay, so the first one I asked you to do here was x minus 3 over x plus 4 is greater than or equal to 2. If you have an algebraic fraction and an inequality, you should multiply both sides by the denominator squared. The denominator in this case is x plus 4. So I decided to multiply both sides by x plus 4 squared. And in that case, the x plus 4 on the left, on the bottom of the left, divides into the x plus 4 on the top on the left, and I'm left with just x plus 4 times x minus 3. On the right hand side here, I multiplied x plus 4 by x plus 4, and I got x squared plus 8x plus 16. If you multiply out the brackets on the left, you get x squared plus x minus 12, and then I multiplied 2 by the bracket on the right, and I ended up with this. At that stage, I decided to move everything to one side because I recognise that I have an x squared, an x, and a number. When you move everything to one side and group your like terms, you get x squared plus 15x plus 44 is less than or equal to 0. And now this is exactly the same as the previous video. We're going to let the quadratic equal to 0, factorize and solve it, and then sketch our graph. So I'm at this stage where I have x squared plus 15x plus 44 is less than or equal to 0. Or I could read that as 0 is greater than or equal to the quadratic. When I'm dealing with inequalities, I can read from left to right or right to left. 0 greater than the quadratic is the same as saying the quadratic is less than 0, less than or equal to 0. But in this case, in order to identify the range of values of x for which this will be true, I need to sketch a graph. And in order to sketch the graph, I need to identify the roots. So to identify the roots, I've let the quadratic equal to 0, factorized and solved it. And when I did that, I worked out that if the quadratic is equal to 0, x equals minus 11 or x equals minus 4. That tells me that this graph crosses the x-axis at minus 4 and the x-axis at minus 11. It's a plus x squared, which tells me it's a U-shape. And only when I've drawn the graph can I actually answer the question asked on this line. The question asked on this line is, when is the quadratic less than or equal to 0? You'll notice I've shaded it in on the curve here. It's less than or equal to 0 when it's below the x-axis. The x values for which this curve is below the x-axis are all of the x values between minus 11 and minus 4. If If I selected, for example, minus 6 or minus 9 or minus 8, any number in this region, the quadratic is below the x-axis, or in other words, less than or equal to 0. So straight off the bat, I can fill this in as an inequality. The x values for which the quadratic is less than or equal to 0 are x values that are larger than or equal to minus 11 and less than or equal to minus 4. I think you'd always start off by doing it like that. However, this is not the correct answer, because you need to recognize in these questions there's an impossible value for x. You are not allowed to have a 0 on the bottom of a fraction. It's undefined. The x value for which the bottom of this fraction would be 0 is minus 4. If I subbed in x equals minus 4, the bottom of this fraction would be minus 4 plus 4, or in other words 0, so the whole thing would be undefined and the whole question wouldn't make sense. So I cannot include x equal to minus 4. My final answer is the range of values of x for which the quadratic is below the x-axis is when x is greater than or equal to minus 11 and less than minus 4, but not including less than or equal to minus 4. So that would give me full marks for part 1 here. The second question was similar. We have an algebraic fraction and an inequality, so we multiply both sides by the denominator squared. And it's partly useful because the bottom of the fraction on the left cancels with one of the x minus 1's on the top. And I'm left with x minus 1 times 3x plus 1, which if I multiply out gives me 3x squared minus 2x minus 1. On the right hand side you multiply x minus 1 by itself and you get this, and then multiply by 2 and you get 2x squared minus 4x plus 2. And at this stage you have an x squared, an x and a number, so you should move everything to one side. When I did that, I ended up with x squared plus 2x minus 3 is greater than or equal to 0. And now I'm going to let it equal to 0, factorise and solve it, and sketch my quadratic. So I let my quadratic equal to 0, factorised and solved it, and I got x equals minus 3 and x equals 1. And that allowed me to roughly sketch my quadratic. The question is, when is the quadratic greater than or equal to 0? It's greater than or equal to 0 when it is above the x-axis. Clearly in this scenario, it's two separate regions, which means I need to give two separate answers. First of all, if I took x values that are to the left of minus 3, the quadratic would be above the x-axis. So to describe that, it's when x is less than or equal to minus 3. Less than or equal to minus 3 means to the left of minus 3. And the second region, clearly when x is greater than or equal to 1 from this graph, the quadratic is above the x-axis. However, I need to refer back to the original question where there's an impossible value for x. If x was equal to 1, then the bottom of the fraction would be a 0. It would be 1 minus 1, which is 0. So it's impossible for x to be equal to 1, so I need to eliminate that. And my second answer is actually just for x values greater than 1, the quadratic is above the x-axis. Let's have a look now at part 3. Okay, the third one was a little bit more difficult because there's a fraction on the right-hand side. Now, what I decided to do was, for the moment, ignore the 5 over 2, and I just treated the question as usual. I multiplied both sides by the denominator to be squared, in which case on the left, x minus 3 divides into one of the x minus 3's on the top. And I'm left with x minus 3 times 2x minus 5. And on the right hand side here, I multiplied x minus 3 by x minus 3 and got x squared minus 6x plus 9. I want you to be aware that in order to eliminate this fraction, at some point I needed to multiply everything by 2. If you multiply the right hand side by 2, then the 2 here is just gone. If you multiply the left hand side by 2, you get a 2 in front. I decided at this line to multiply everything by 2. Remember, I want you to look at the right hand side here. If you have 5 times this, but it's 5 over 2, another way of viewing that is as if the whole thing is over 2. I could have just viewed that as if the whole thing is over 2. It's the same. I could write it like that, or I could just write it as 5 over 2 times the fraction. So when I multiply everything by 2 at this stage, the 2 on the top and the 2 on the bottom simply cancel, while on the left hand side it's 2 times all of this. You could have multiplied by 2 at the very start as well if you wanted. I just wanted to do it step by step. So what I've done to get from this line to this line is I've multiplied x minus 3 by 2x minus 5, and I got 2x squared minus 11x plus 15. And I've also multiplied everything by 2 so that I would end up with the 2 on the left and no more fraction on the right. At this stage I just multiplied 2 by this quadratic and 5 by this quadratic, and I ended up with 4x squared minus 22x plus 30 is less than or equal to 5x squared minus 30x plus 45. I decided then to move everything to one side because I have a quadratic equation. And it's easier to move everything to the right hand side because the value for x squared is larger, and it means I'll have a plus x squared. When I grouped everything, I ended up with 0 is less than or equal to x squared minus 8x plus 15. And now we're just going to let it equal to 0, factorise and solve our quadratic. So what I've done is I've let my quadratic equal to 0, I've factorised and solved it, and I got x equals 5 and x equals 3. This tells me now, I can now sketch my quadratic. It's a plus x squared, so I know it's a U shape. I know it crosses the x-axis at 3 and the x-axis at 5. So now that I've sketched my graph, I'll look back at my inequality. This line reads as when is the quadratic greater than or equal to 0? The quadratic is greater than or equal to 0 when it's above the x-axis, or in other words, when it's to the left of 3 or to the right of 5. If I'm talking about x values that are to the left of 3, I'm talking about x values less than or equal to 3. And if I'm talking about values to the right of 5, I'm talking about x values greater than or equal to 5. However, notice that it's two separate regions, so it has to be two separate answers. And then don't forget to look back at the original question to see is there an impossible value for x. In this case, it is impossible for x to be equal to 3. If x was equal to 3, the bottom of the fraction would be a 0, and that's undefined. So I have to eliminate that. X cannot be equal to 3. My answers are x. When x is less than 3, the quadratic is above the x-axis, and when x is greater than or equal to 5, the quadratic is above the x-axis. So these are my two separate answers for the last part of this question. This finishing off questions like this is going to pop up quite a lot. In anything we do in maths, if you have an inequality and a variable to be squared, like a k squared, or if you have anything to be squared in an inequality, you should always finish your question like this. Like for example, let me just show you another one. If you got something like k squared minus 4 is greater than or equal to 0, you're not going to factorise that one as a quadratic. To factorise k squared minus 4, you're going to write it as k minus 2 times k plus 2. You're going to factorise it as the difference of two squares. But in a scenario, and we will come across this later on in algebra, this one you would have to sketch your graph exactly the way we've done it, identify when is the quadratic greater than or equal to 0. Remember, we call an x squared an x and a number quadratics. That's factorising quadratics. But in fact, just a variable to be squared is a quadratic. K squared minus 4 is a quadratic. We just factorise it differently. But once there's a variable to be squared, we are always going to answer the question like this. So just be aware of that as we move through the rest of the topic.